Look at equivalent fractions. If you look right here, you're going to see that I have 2/5. Now I'm going to find out how many tenths it would take to be the same amount. And I'm very carefully pulling these tenths in. And according to the math, 2/5 would be exactly equal to 4/10. So let's look at these fractions and see if we can 5th grade style prove that they are indeed equivalent. Look at these numbers. I can divide the top number by 2, and whatever I do to the bottom, I have to do to the top. And as long as my insults match each other, the do-do rule, big sister, little sister rule, then I'll know that I made equivalent fractions. Let's look at another one. I've got 1/2. 1/2 is pretty simple. But how many fourths would it take to be equal? The same exact amount, different numbers, same amount. And according to the little chart, it looks like we would have 2/4 that would be equal to 1/2. So let's look at 5th grade style and see if we can prove it. Look for your insults, times 2 on the top, times 2 on the bottom. These are exactly equal. I want to look at one more of these bad boys. I want to look at 2/3. We've got 2/3. And what if we wanted to find out 5th grade math style how many 12ths it would take to make these 2/3? Well, I can do that because I can look at 3 and think, what would I do to 3 to get 12? Times 4. Whatever I do to the bottom, I have to do to the top. And lo and behold, according to the math, it should be 8/12. Let's go ahead and build this and see if indeed these two fractions are equivalent. According to our math, we think we're going to need 8 of these little 12ths to make an amount that is equal or equivalent. Remember, equivalent is just a fancy way of saying the same. And this is taking me a second because it's a lot of dexterity needed to accomplish this task, but it's happening. So far I have 1, 2, 3, 4, 5, 6, 7, and one more. Indeed, it works out pretty magically.